each other. Oh, I didn't have it turned on. That first minute's going to be horrible. Oh, well. Okay, it's on now. Sorry, whoever's watching. All right, so we've got, if you would have, say, 1/2 times 2, those are inverses of each other. Because when you multiply them, you get the identity, which is 1. And if you would take -5 plus 5 and add them, you get the identity, which is 0. And if you take a function and operate the inverse on it, you get the identity, which is the input, or x. So we've seen inverses in action. Well, log base a of x and a to the y equals x, those are inverse things, okay? So let me show you why they're inverse things. Take out your calculator. And we learned that functions are inverses when they're reflected over the line y equals x. So I want you to go into y equals, and let's punch in y equals x. The second thing we're going to punch in is we're going to punch in log. Now, log is over here on the side by the 7. And notice that it doesn't define what the base is. Do you know what the assumed base of a logarithm is? 10. 10 is the assumed base, unless it's written. 10 is assumed. So I have log of x. Well, hi there, Nissa. We missed you. Christine was crying. She'd been crying. And then we want to punch in the inverse, which would be 10 to the x power. So log of x and 10 to the x, those are inverses. And if they are inverses, when we graph them, one should be reflected over the line y equals x. Well, you remember the graph from the other day. Well, I'm sorry. Let's zoom. We'll zoom standard. Sorry. Zoom 6. Standard viewing window. Look at my first graph. It goes like that, and my second graph goes up. Remember yesterday we looked at the graphs on the top, they go up. What point did they pass through? 0, 1. So if it's reflected over the line y equals x, this was going to pass through 1, 0. They are reflections of each other over the line y equals x. So they are inverses. They undo each other, okay? So let's apply that, and I'll show you exactly what happens if a logarithm and a base to an exponent undo each other. Then log base a of a to the x, the log base a and the base cancel, and you're just left with x. And if you take a to a log base a power, those also undo each other, and you're left with just x, because they have an inverse relationship. Now, you're not going to be asked to do that a lot, and if you do have questions about why that works, I could show you. But generally, people just kind of trust it. We move on. Somebody asked second hour, and I showed them. They said, well, that helps a lot. But I'm afraid if I do the whole class right now, we'll kind of forget what's happening. So it says, express the following in exponential form. Note that we said if you have log base a of x equal to y, that implies a to the y power, to the y power is equal to x. Okay? So I want to write this in exponential form, which would be the second piece right here. So what is the base in this problem? 2. What's the exponent? 5 equals 32. Is that true? Yep. 2 to the 5th power is 32. What's the base for problem B? What's the exponent? Equals 36. Is 6 squared equal to 36? Yep. Log base 12 of 1 equals 0. That would be a base 12 to the 0 power. Anything to the 0 power is 1. What's the base for D? 3 to the 4th power is 243. Nope. So this logarithm is actually incorrect. I wrote it. I made up all these problems in my head last night. Sorry. And actually, the log base 3 of 43 is actually 5. It's 3 to the 5th power is 243. Sorry about that. Thank you, Tyler. You're very forgiving and understanding. Now, people got confused with E and F. Those are natural logarithms. A natural logarithm doesn't have a base of 10. It has a base of E. E is the base. So what this really means here is the logarithm base E of E is equal to 1. So how would you write that in exponential form? E to the 1 is equal to E. Is that true? Yes. And the second one, natural log of 1 is 0. That would be the log base E of 1 is equal to 0. Or E to the 0 power is 1. Anything to the 0 power is 1. So we've written them. Do you remember doing some of that from last year? Okay. Oh, sorry. Levi and Tyler and Jed and Kim. Do you guys remember doing that 2 years ago? So this was a helpful introduction. Okay. Let's do the opposite. Let's express them in logarithmic form. So I would have a log. What's the base? 2 of the number 16 is equal to the exponent. Logs equal exponents. What's the exponent? 4. That's the way you would write that in logarithmic form. I don't know where the word logarithm comes from. I should figure that out. You guys would probably enjoy that, right? Macy, you would like to know, wouldn't you? Yes. All right. Thank you. I'll go to work on that. All right. This one will be log base what? Do I have to write 10? I don't, because 10 is the assumed base. So I'm not going to write it. You sure can. The log of 10,000 is 5. 100,000. Sorry. Thank you, Tyler. All right. We got 8 to the negative 2 equals 1/64. Log base 8 of 1/64 is equal to negative 2. So my exponents are what the logarithm is equal to. Why don't you see if you can do D, E, and F? Quick try to punch out D, E, and F. See where you get. Okay, please take a look up here. Make sure we have the same things. Log base 7 of 1 is 0. That's what you should have there. Log of 1/10 is equal to negative 1. If you wanted to write a base of 10, that would be fine. And then log base E of E is equal to 1. I don't write log base E. You can't do that. You have to transfer it to natural log. Okay? If you want to write a base 10, that's fine. But if you see log base E, you must think to convert that to natural log. That must be the case. No, if it's the only time you do it is if the base is E. That's the only time you convert it to natural log. Okay. And kind of interesting, I did some logarithms this summer when I was doing I was doing some calculus within my statistics class, and natural logarithms are extremely useful in doing proofs and carrying out all sorts of things. They just work really nicely in mathematics, especially in calculus with derivatives, so we like them. Okay, evaluate the following expressions. Okay? Log base 4 of 64 equals what? Well, that's saying that 4 to some power, I'll write question mark, is equal to 64. So what is the log base 4 of 64 equal to? 3. Log base 3 of 1/9. That would say 3 to some power is equal to 1/9. Oh, that's a little bit different. Negative 2. I square it to get the 9, and then because it's in the denominator, it's to a negative power. Log base 8 of 8. Very good. 8 to some power is 8. namely the first power. So again, logarithms give us exponents. They give us exponents. Uh-oh, this was kind of tricky. Log base 5 of 5 to the x plus y. Yeah, these undo each other, okay? Those are inverses, so you're just left with the exponent. How about the next one? 7. Yeah, the 3 and the log base 3, those undo each other. They are inverses, and you're left with 7. You like that one, Levi, don't you? All right. And then natural log of 1 over e squared. So I would have, let's see, this would be e to some power is equal to 1 over e squared. Right, -2. So, Whitney, you had a question? This part? Let me change it. Would you agree that I could rewrite 1 over e squared as e to the -2? So then this problem can change. This problem could read the natural log of e to the -2. You're saying that those are the same expressions, right? So that means e to what power equals e to the -2? -2. Does that help? Okay, backside. Notice how many problems we've been able to get done here pretty quickly. We got 10 more. It says find x, and this time we're in a little bit difficult situation because x is different in each one. So we have to be able to interpret it correctly. And this one says a base of 2 to the exponent of 3 is equal to x. So what is x? 8. Could somebody tell me how I would write this next logarithm in exponential form so I can understand it? Good. So x is 10. How about the next one? So x is 3. Next one's tricky. Base x to the 1/2 power is 49. What does it mean to take something to 1/2 power? Square root it, right? So the square root of some number is equal to 49. So x is 7, right? No. You got to square 49. So x is 2,401. I think that, well, we did this second hour, so I knew 2,401. But I think that when I wrote this problem last night, I probably wanted to come up with the number 7, but I probably mixed something up. But there's still an answer. So it's actually good I put it in there that you can't just think about, the numbers. You got to actually think about what's happening. So some number we take the square root of to get that, and that happens to be 2,401. Is it not 2,401? 49 squared? Okay. Log base 2 is 0. Here, this is a tough one. I did intend on this one. So we have base of 2. Hey, base of 2 to some power is equal to 0. Can you take a number to a power and get 0? If you go to your calculator and you type in a log of 0, if you type in log of 0, you get domain error. You don't have a result. In fact, if you look at the graph, this graph, it approaches 0, but it never touches it. So, therefore, it doesn't work out like that. Okay, log base 10 of x equals -3. So that would be base 10 to the -3rd power equals x. So what is x? 1 over 1,000. Good. And now 5, we'll pick up with these 4 problems. These are similar to what we had yesterday. Now note that instead of passing through the point 0, 1, these all pass through the point 1, 0. That makes them different. So we want to write a graph, and somebody noted second hour very wisely that um, that you could write an equation for a line that passes through those points. You could write all sorts of equations. We just want to find a, not the, but just one of the equations that would be in logarithmic form. So there's infinite many results for equations, but we want to find a logarithm one. So pass through 1, 0, and then 25, 2. So I'd be way out here at like 25, and I'd be up, say, 2 units. So, you know, the graph looks something like that, okay? It's a logarithmic graph. Now, follow the first one because this is where it's confusing for people. I have y equals log base a of x. What is my y value in this problem? Let's use that coordinate. 2 is y equals log base a, which we don't know. What is x? 25. So the question is, what number do I square to get 25? 5. So a is 5. So my equation would be y equals log base 5 of x. That is the equation of that graph. So I had to think through that a couple times. If you didn't get it the first time, don't worry, we'll do a few more. The second one passes through 1, 0. I'll plot that point. And then 1/6, -1. So if 1/6 is here, -1 might be there. The graph looks something like that. Okay. And I again have y equals log base a of x. What is my y value? -1 equals log base a of 1/6. So that means the way I would interpret that would be base a to the -1 power is 1/6. What number do you take to the -1 power to get 1/6? 6. So my equation would then be y equals log base 6 of x. See if you can do C and D on your own. Try C and D on your own. For the first one, I wrote y equals log of x. I didn't write base 10 because 10 to the 4th power is 10,000. I don't want, my screen's been flashing today. I don't know why. And then y equals log base 7 of x would be this one because 7 to the 1st power is 7. Okay? All right. Well, here's your assignment. It looks like a lot of problems, but we just did like 40 problems right now. So they go fairly quick. 1 through 16, 23 through 27, and 35 through 38 on page 356. That would bring you to a good spot. How are you guys doing on your homework? You're all caught up? Okay, up until this massive assignment. All right, well, I'm unplanned for tomorrow right now, but I'll think about, but we will have something to work on, but expect a decent amount of work time tomorrow as well. So, but please do get started on this.